Okay, now it's recording. Perfect. Thank you.
Okay. Sure. Let me. All right. So just to start again, just to recap that SQL is a querying language. It's a declarative language, so it specifies what to do. It is a data manipulation language in the sense that it lets you manipulate data, modify data. It's also a data definition language, so it defines how the database looks like, what are the schemas, etc. And then there are many uh, non-standard variants or whatever the constructs that different versions of SQL support. So it differs from which SQL you are using. For example, whether it's Oracle's MySQL or the open source MariaDB or Microsoft's SQL Server, etc. And it may also differ from one version to another. So please do look up the manual of the particular SQL that you're looking for, the non-standard options. What we will study mostly are the most common usages and the standard SQL constructs. Okay. And here is an example schema. This is a real life example schema that we will study in detail. Okay. So just to understand the semantics of this, so there is a course relation. Okay. And there is an attribute called code, which is underlined. So if this is underlined, it means this is the primary key of that relation. Okay. So for every course, there is a code. And of course, there is a title of the course. There is a type of the course and a web page. Okay. So for course type, there is another relation called course type, which is this. It has the type, which is a primary key, and there is a department. Now note that this C type on the course, this is italicized or emphasized, right? This means that this is a foreign key, and this foreign key refers to this course type. Okay. Please do remember what was the foreign key. The foreign key is something that refers to a primary key of another table. For example, here this DEPT is a foreign key. This refers to this department. So which department offers this course type? That's essentially what the meaning is. Similarly, we have defined different other relations. So there is a faculty member with the primary key as faculty ID, then the name, which department the faculty member belongs to, and her designation. The department has an ID and a name. A semester has a year or half, and if it's a trimester, a quarter, you can have a year, then first quarter, second quarter, third quarter, whatever. There is an offering. So what is an offering is that a course is offered multiple times. So a particular course code is offered in a particular year and a particular half by a particular instructor. So this entire thing is one offering, and the entire thing is the primary key. Okay. Similarly, a student has a roll number, which is the primary key, and a name, the department that the student belongs to, and her CPI or the grade, whatever you want to call it. There are programs, so a student maybe of a bachelor's degree program, master's degree program, PhD degree program, etc. So which program is it, and which is the type of the program. Then there's a registration saying which student has registered in which course. So in this course, particular course, which roll number, so which roll number student has registered in which year and which half, and what is the final grade that this that the student got. And then there is a grade table which says, okay, what does this grade actually mean? What is the value of this thing? All right. So please do stop me, and please do type in questions if you have any. And otherwise, please do tell me if this is making sense. Okay, this is an example of a real life schema that may be used for the academics, for managing the academics of an institute. Okay, and we will see how this can be used in real life examples. Okay, all right, fine. So the first thing is, well, how to create these relations. Okay, so there is a construct called create table. So please do note the convention. If things are written in this blue font, which means these are actual kind of codes that you can type in. Okay. So create table is an actual command that you can type in. And you see the example actually gives you the exact things that you can type in to get this. So once you have a database open in an SQL system, you can actually create table. You can actually say create table faculty, then these brackets, and the attribute name, the type of the, what type of an attribute it is. So I say that FID is an integer and it's the primary key. Then I say name is varchar and all those things. Okay. So this is actually, you can type this in, and at the end of this, there will be a table called faculty that is created. Please do remember that this is only creating the table definition. There is still no data in the faculty table. Okay. For inserting the data, you have to do something more, but this just tells you that there is a table called faculty. This is like opening a file. When you open a file, when you say file open new, it only creates a new file, but there is no content in it yet. So this only creates a table faculty, but there is no content in it yet. There is no data in it yet. Okay. All right. So there are different types of data that you can use. Yes, I'll come to, there's a question on this varchar, etc. and all those things. I'm coming to that. So there's different types of data. And the first is called a character. So char n. So this means that this has to be a character string of fixed length n. Exactly n things. And then there is something called a varchar, which is a variable. So it can have up to n. So if I go back, you can see that there is a varchar 50 on this name. So which means that I am allowing names of up to 50 characters, up to 50 characters. It doesn't need to be exactly 50, but if it is more than 50, the 51st character onwards will be trimmed away. But it can have up to 50 characters. And similarly, I can have a designation which can be up to 3 lengths. I mean, 3 character length. That's all. Okay. All right. Then there is another question called what is not null mean? What does not null mean? Fine. So remember what we said about null is any value that says that this is missing value or unknown value. When I say this name is not null, that means I cannot have a faculty member whose name is null. So whose name is missing or unknown. So essentially, in other words, for every faculty member, I must know what the name is, what her name is. So it cannot be null. By not null, I mean it cannot be null. Okay. All right. Now coming back to this you can study later on. So integers are integers, and there are short integers and all those things. There are real numbers. So I mean, so an integer is like 1, 2, 3, 4, etc. Real numbers can be 3.14, 2.13, whatever, all those things. Okay. Right. Then the newer versions of SQL support this date, time, timestamp, interval, all of these things. You may think that what is special about having a date type? This is mostly like a string, right? This is DD format. This is mostly like a string. But what if you put it as a date field? Then what you can do is you can take the difference between two dates. So you can say, for example, 2nd February 2020 minus 14th July 2019. It will actually give you the number of days that has elapsed, right? If you put it just like a string of characters, then if you take the difference, it has got no meaning. It will not calculate the number of days. So date and time, similarly, if you have the date time, let's say 20 hours, 48 minutes, 7 seconds, you can take a difference saying, okay, what is the difference of that with let's say 15 hours, 20 minutes, 19 seconds or something like that. So that's why this date and time are special data types that you can use in SQL. Okay. All right. One important thing that databases have to handle regularly, especially new databases, is that there are many large objects such as the images, videos, etc. So, for example, I mean, an academic system may want to store an image of every faculty member and every student that is there. So, how are those images stored? There is something called a blob, BLOB. So, it's a binary large object, which is essentially what happens is that instead of storing that exact image as in the table, the image is stored as a file somewhere else, and a pointer or essentially a link to that file is stored. So which is better from the efficiency point of view, because every time I need to read the table, I will not read that entire image, but I will just have a link. Similarly, there can be this character large objects, which is very large string essentially. So that's just a technicality. Okay. So while creating a table, there can be different constraints. The first constraint, as we have already discussed, is that this is not null. When you say null, the attribute cannot be null, cannot be just. So in general, when you do not know the value of an attribute, and you can just skip it as null. By default, it may be null. Okay? But if you say not null, it has to have a value. Okay. Then the second one is, of course, easy to say, primary key, and the primary key is A1 to AJ. So by this notation of primary key, what is meant is that together, AI to AJ together is the primary key. It does not say that AI is a primary key and separately AJ is also a primary key. No, that is not correct. What is the primary key is together, all those attributes together is a primary key. Okay. Fine. Then the third constraint is default n. So which means that if I do not know the value, I can say default n. So if I do not know the value, it will by default take the value of n. Okay. Then the fourth one says it is unique. So which essentially means that, look, there's a candidate key. It has to be unique for everybody. Then the fifth one is a foreign key, and this we have discussed earlier. What does a foreign key mean? That it has to come from some other department. And then there is a check P, a predicate must be satisfied. So let's go over this example of creating a faculty in more detail now. So the first one, it says create table faculty FID integer. So which means that there is a field called FID which has an integer. The second thing means this is a name which is varchar, not null. So there can be up to 50 length and this cannot be null. Then it says there is a field department integer. There is a field designation varchar. Then it says that the primary key of this table is FID. It says primary key FID. Then it also says that department, this is a foreign key, this foreign key department. And when you say foreign key, you have to say a foreign key means it refers to some primary key from some other table, right? So which table does it refer to? It references this department table. So that means there has to be another table called create table department, etc. And this department, so this foreign key refers to that department. Okay. Then there is a check constraint, which means that FID greater than 0 check. So that means that no faculty member can have an FID which is less than 0, which can have a negative FID. This is just a check. This is putting a check. Now, this also tells you why databases are much more powerful than file systems, etc. Because you see this foreign key, primary key, check constraints, not null. This cannot be enforced very easily in a file system or in an Excel spreadsheet. This is not so easy. But once you put data, once you define things like this in a database, this is much more easier. This is actually done directly. All right. So please do ask me questions if there are any on this create table. Great. Let's move forward. Now that we have been able to create a table, there should be a way of dropping or deleting a table. And the delete table is essentially very easy. It's just a drop table. That's it. So for example, if you say drop table faculty, it drops the table. More importantly, even if there are some data in the table, in the faculty table, it drops all of that. So it deletes all the data, and it also deletes the definition that there is a table called faculty. Okay. So it's actually like deleting the entire file with all its contents, and the whether there is a file or not, it's not even after this you cannot say what is faculty, etc. Okay. This is deleting a table. Then there is something called modifying a table. So modifying meaning, suppose I have created this thing and I want to add some more attributes. Okay. So there is a command called alter table. So I can say alter table R, that means please modify this table R. And let's say I'm saying, okay, please add this attribute A whose domain is D and the constants are C. Okay. So for example, I can see this example, alter table faculty. That means, well, I want a change in the faculty table by adding another attribute called room, which is a varchar 10. Okay. Similarly, I can also say, please do drop an attribute. This attribute is no longer required, so I would want to drop this attribute. For example, I can say alter this table course by dropping the web page. So what it means is that in this course, the other data remains as it is, but the web page column is dropped, is deleted. So there is no more the web page column. There is no more, you can say, course, what is the web page of this course, etc. You cannot say that. Okay, fine. All right. So this really lets you delete or modify a schema. So this lets you describe how things, this lets you describe what are the relations. There is still no data that is being put into it, okay? Before putting data any further, what I would like you to actually study is this called the querying. So now assume that there is this tables created and assume that there are data in the tables, okay? Now the most important part comes, which is how to query this, okay? So as I said already, that SQL is based on relational algebra. So we studied relational algebra a little bit, but we'll see more detail. And a basic SQL query has this form of select some attributes from some tables where some predicate, okay? So each A, J, etc. is an attribute. So each of this Ri is a relation or a table, and this P is a predicate, okay? All right. Now, if you remember this, what it means is that I will find out everything that is from these relations, and I will apply this filter P on that. From whatever is left, I will select those attributes. Okay. Now, let's go over each of these select from where in much more detail. Okay, let's go. But very importantly, first thing, even before going there, please do remember that SQL relations are multi-sets, or bags of tables, not sets. The relational algebra are sets, so this is bags of. So what does a multi-set or a bag of tuple mean? Essentially, in a multi-set, an element can occur twice, which is not there in sets. So there may be two identical elements, identical tuples that can occur twice. So for example, I can have, let's say, A, B. I can have this in a multiset. I can have this the element A occurring twice. So I can have A, B, C, D, E, all those things, right? Remember, in a set, I could not have that. In a set, B is invalid. I can only say AB because that element A cannot occur twice. However, in SQL, relations are multisets or bags of tuples. So then I can have a tuple occurring twice or any number of times. Essentially, it is not restricted to be once. All right, fine. If you want that to be restricted to once, you can have this keyword unique or distinct. But the opposite is the keyword all, which is by default. By all meaning I want all copies of it. And distinct meaning I want only distinct copies of it. And unique, of course, mean the same thing, that I can have only unique copies of it. Okay. Fine. Let's then go back to this relational algebra a little bit, because this is needed to study the SQL construct. So remember, if you have this kind of thing, project A1 to AK from a relation R, which means that from this relation R, I only choose the specified attributes A1, A2 up to AK. That's all. I do not do anything more. Okay, that is relational algebra. That is the project in relational algebra, and the schema is changed. So just to refresh our mind, if we actually do this project A, C on this table, what remains is only the columns A and C. So the first thing that comes is 1, 5, and then that is repeated. Now, because relational algebra is set, There is only one copy of 1, 5 remains, and then 2, 5 remains and 2, 8 remains. Okay. For SQL, what would have happened is that it would have written 1, 5 and 1, 5 twice. Okay. All right. So the select operator in SQL is actually built upon this project operation in relational algebra. Okay. So it just lists attributes in the final output. Okay. So for example, now if you have a query called find the codes of all courses offered in the year 2018. Suppose I want to do that. I want to find in an institute, particular institute, what were the courses that were offered in a particular year. How do I actually translate it to an SQL query? You can do it in this manner. You can say select course code from offering where year equal to 2018. Okay, please let's take some time to understand this particular query. So what does this mean is that, look, I am interested in the offerings of a course. Okay, so that's why it is a from. So from offering, I'm interested in that offering. Then, although I'm interested in offering, I'm not interested in all offerings of everything. I'm interested only when the year of a course offered is 2018. So this is a filter that I want to apply on that. Right? Now, even from all those courses, I'm only interested in the course code attribute. I'm not interested in the other attributes of the courses. Because I only want to say find codes of courses, okay, not everything. So then I say select course code. Okay, so which means that from the table offering, I have filtered out tuples. I have only those tuples where the year of that offering is 2018. And from that, I have filtered out only the attribute course code. So that's really the meaning of this select course code from offering where year equal to 2018. Okay. Great. If you have questions, please do type it in, or please do actually unmute and ask. Fine. Okay. So SQL is case insensitive to, you can write this select as on small, or all caps, whatever, doesn't matter. There is a shortcut called select star. The select star actually chooses all the attributes. So if I want to choose, if I'm interested in all the attributes from this offering, then I can just say select star from offering where this is. And just earlier I said, well, it retains eliminates. It retains duplicates. So to eliminate duplicates, you can say select distinct by, otherwise by default is select all. Okay. All right. Fine. So any questions on this select? Fine. So it can also contain arithmetic expressions. So the select can also contain arithmetic. So for example, if I do this, select course code year minus 1959 from offering where year equal to 2018. What will this do? The same thing. So it will first go to the offering table, find out all tuples from it. Then from all those tuples, it will filter out only those tuples where the year is 2018. Great. Then from those tuples, it will get this attribute course code. In addition, it will also create another attribute, which is called year minus 1915, and it will actually do that arithmetic for you. So essentially what will happen is that everything will have this 2018 minus 1959, so which is 4900. Everything will have that value, but it will actually do that mathematics for you. Okay. So it can actually contain, it can actually do these arithmetic operations. Great. We can move forward. Okay. The second important concept that we need to study is something called the Cartesian product in relational algebra. So a Cartesian product, and you can see the symbol is essentially just a multiplication symbol. It actually does a multiplication of these two relations. So let's see. What does it mean is that if you have one relation which says, which has got only these two attributes A and B, and the other relation which has got these three attributes C, D, E, what it will do is it will have a relation which has got all the attributes. So the attributes there will be A, B, C, D, and E. Good. And the tuples, there will be a multiplication of all. So multiplication meaning it's a combination of all the tuples. So the combination is that 1, 1, 1, 2, 7, then 1, 1, 2, 6, 8, then 1, 1, 5, 7, 9, then 2, 2, 1, 2, 7, 2, 2, 2, 6, 8, 2, 2, 5, 7, 9. So it's all combinations, all the combinations. You see there are 2 and 3. So it's all the 2 times 3 combinations. So all the 6 combinations are there in a Cartesian product, okay, of relational algebra. Fine. Okay. All right. So great. So how is that related to this SQL? The from, in the from clause of SQL, where you list down relations, this is actually the Cartesian product of the relation. So when you say from relation 1 comma relation 2, what it does is actually creates a Cartesian product of the relations R1 and R2. Okay. So when you say find title of courses offered in 2018, what it will do is that it says, sorry, so from course comma offering. Now please do look at this. This is the syntax, course comma offering. What does course comma offering will do is that it will create the Cartesian product of course times offering. Okay. And in each tuple in the Cartesian product, what it will do is it will filter it out based on this condition. Okay. Now what is the condition? The condition is that the course.code must be equal to the offering.course code. Please do note the syntax as well. So course.code, which means that I am referring to the attribute code of the table course. Okay, that is course.code. Similarly, I am referring to the attribute course code of the table offering. They have to agree in that Cartesian product table, okay, in the tuple in a Cartesian product. And the tuple must also satisfy year equal to 2018, okay. Now, do note again one important thing is that I have just specified year. I have not said offering.year, okay. Why can I say why can I just say year? The reason why I can just say year is that in these two tables, course and offering, only one of the tables has this year attribute, which is the offering. The course does not have the year offering. So when I say year, there is no ambiguity. When I say why year, I am sure I am referring to the one that is in the offering. I am not referring to anything else. Right? If, however, there was an ambiguity, for example, suppose for some tables the year is both course and in offering, then we have to say both relation 1 dot year, or I mean you have to specify that whether you say relation 1 dot year or whether you say relation 2 dot year. You have to, I mean, you have to disambiguate. Right? Here you because there is nothing to disambiguate, you can use. Okay, fine. So let's go over it once more. So when you write a query like this, it creates a Cartesian product of course and offering. Then from each tuple of in that Cartesian product, it filters this out based on that, and then finally it only selects the title attribute to be output. Okay, clear? Okay. All right. So of course, we have already said this. When two relations contain attributes of the same name, qualification is needed to remove it. Okay, let's do one more example. So find roll number of students in BTech program, and you can have this. So because I want the BTech program, I have to say student at program. I say student.roll, comma program.roll, and program.btype equal to BTech, etc. Note how strings are used. Strings are used literally with quotes, double quotes. Double quotes to, so double quotes essentially say that this is a string. Okay, fine. All right. Great. Now comes the select in relational algebra. Now, this is historically a problem, saying that the select in relational algebra is different from the select in SQL. The select in SQL is actually equal to the project in relational algebra, and the select in relational algebra is equal to the where clause in SQL. So the select in it matters where is this select happening, okay? Whether it's the whether you're talking about the select in relational algebra or the select in SQL. Okay. So the select in relational algebra is essentially the selection predicator. How you should, so if it's a sigma p over a relation R, what you are doing is that it selects all tuples from R that satisfies the predicate P. Okay. So again, let's just do an example. If this is ABCD and you say select every tuple where A equal to B and D greater than 5, then what happens is that the first tuple passes because A equal to B and D greater than 5. Second one does not. The third one does not. And the fourth one does. So that's all that it's doing. Okay. This is equal to the where in the SQL. Sorry. So it specifies the conditions, so that precisely the same thing as what the select in relational algebra does. Okay. So for example, you can say this year equal to 2018 is the condition that you want to specify. You say select course code from offering where year equal to 2018. Okay. So that's the condition you want to specify. Okay. Of course, it can use this and or not to connect the predicate. So you can say year equal to 2018 and instructor equal to 10. So what this does is that essentially it is saying, oh, please find me all the courses that instructor number 10 taught in the year 2018. So I'm saying year equal to 2018 and instructor equal to 10. Okay. Both, because it's and. So, I mean, a tuple passes this filter only if both the conditions satisfy. Great. You can, however, leave this where clause. It's not mandatory. So if you leave it, it's essentially equal to where true. I mean, if you just say select course code from offering, it selects every tuple. So every tuple passes that. Done? Okay. So the SQL also allows the between operator. So the between operator is, I can say year between 2016 and 2018. So when I say between, this is inclusive. So this means any year which is 2016 or 2017 or 2018, right? Because it is between. Okay. Great. So after these three basic things, there is something called a rename operation. The rename, to rename, it is using as. So the reasons why renaming is useful is because first of all, to actually rename it into a better name. So for example, instead of saying student dot roll, I can say roll number, which is much more used. I mean, what is intuitive to understand and intuitive to use further if you want to use. Okay, so that you can do. However, something more important, there is a more important usage of renaming, which is when the same relation is used twice. So for example, I will say find names of students whose CPI is greater than that of the name that student whose name is ABC. So please, let's try to understand, deconstruct this example. So what does it mean? Is the following, is that there is a student whose name is ABC, fine. Find out the CPI of that student and then find out everybody whose CPI is greater than that of the thing. Okay. So one way of solving this is that I use the table student twice. This is very, very interesting. I'm using the table student twice. Okay. And I am renaming them. So the first usage of the table student, I am calling it as T, capital T. The second usage, I am calling it as capital S. Okay. Now, and then once this is renamed as T and S, I can say T.cpi, I can say S.cpi, I can say S.name, I can say T.name, etc. Now, please understand that here the renaming is necessary. It's not only for, UI purposes. It's not only for aesthetic reasons. This is necessary. Why is this necessary? Because if you do not rename it, suppose you just say from student comma student, okay, and then you say where student.cpi greater than something, or greater than even say 8 or something. Now, when you say student.cpi, which student table do you mean? Do you mean the first instance of it, or do you mean the second instance of it? So that is ambiguous. Therefore, to ensure that there is no ambiguity, they must be renamed. They must be renamed as student as T and student as whatever. I mean, whatever names you choose, and then they can be, once you have renamed it, you have to use those names. So you can have to say T.cpi, you have to say S.name, and so on. Okay. So is that clear? Why is renaming used, and why in some cases renaming is necessary? Okay. All right. So SQL can use string operations. So for example, if I want to find all departments having engineering in its name, I can just say name like percentage engineer. So percentage is like any set of characters. Any set of characters can fit percentage. But this is, remember, this is not equal to, this is, I mean, so this is, so I cannot say where name equal to percentage engineering. Name equal to meaning I'm trying to match it literally. While if I say name like, that means I am trying to do it in this regular expression manner. Okay. So similarly, I can have this thing where name like percentage. So this is only one character. Okay. All right. Fine. Okay. Now let's go to something called ordering of tuples. Now, mathematically, what SQL returns is a multi-set or a bag of tuples, right? And the order in which the tuples occur in this thing is unspecified, in the sense that, see, because two multi-sets, for example, A, B is mathematically the same as saying it A, B, A or B, A. They're mathematically the same. So SQL part say do not distinguish, so the SQL does not distinguish between AAB and ABA because these are both multisets. But sometimes for display purposes or for other purposes, you will want them to be displayed in a particular order, right? So for that, there is this clause called order by. Okay. So this is for sometimes, so this is essentially just for display and has no effect. No actual effect, in the sense that mathematically there is no difference by whether you do ordering. So for example, if you want to order departments by name, which is a very common thing, I want to order departments by name. So I can say select star from department order by name. Okay. So you are ordering by name, which means that, which means that you want them to be ordered according to the name. Just one second, there is a problem with this thing. Yeah. Can you all see me? Yeah. Okay. Yeah. So which means that I will, so in the display, I will have them ordered by the attribute name. Okay. So by default, this is the ascending order, but if you want descending order, you can use this by descending. Okay. By the default is, of course, ascending order, ascending. Yes. Okay. Great. Okay. So any questions? All right. So then we can have the set operations. One important thing is that when you work as sets in SQL, they go back to the set thing. It's no more multi-sets. So it eliminates the duplicates. Okay. And so how are this set union, set intersection, and set difference occur? So for example, if you want to say find names of all faculty members and students, so what is the way to do it? You find names of all faculty members, you also find names of all students, and then take a union of them. So union is essentially adding up everything, and intersection is retaining only the common portions in it. And the except or the set difference is that whatever is in the first thing but not in the second, that's what you are. I mean, if it is in the second, then you get rid of that. So it's essentially things that are in the first but not in the second. Okay. Coming back, how do you solve this query? Find names of all faculty members and students. You just say select name from faculty, union, select name from student. That's all. Okay. Similarly, we can do something like find names of faculty members not found in students. That is essentially except. Okay. You can say select name from faculty, except select name from student. All right. Okay, great. Next comes a very, very important concept, which is called aggregation. And we'll see aggregation and grouping. This is very, very important. Okay. So aggregation, so there are, I mean, so what are the common aggregation things that can be done is average. You want to average, you want to find average of certain things. You want to find the minimum or the maximum or the sum total of that or the number of things that is there, the count of this. So the aggregation, so let's, without worrying about the relational algebra syntax, let's just see. If you say aggregation, sum C on this. So what does it supposed to return? It is essentially saying that, look at the column C, take their sum. So essentially it says, look at the column C, take their sum. So it will be this, what is the sum? It's 5 plus 5, 10, plus 5, 15, plus 8, 23. So it will only return directly this. That's all that it does, right? Okay. However, you may want to say that, look, I want to do this aggregation, but I first want to group them. So I do not want to do it on the entire table, but I want to group them based on certain attributes, and then I want to do it. So that is also there. So then I can say that first group them based on this attribute A. So what is the attribute A? The attribute A is 1, 1, 2, 3. So how do you group them? So when you want to group based on this attribute A, so what happens is every tuple that shared the same value of A becomes part of the same group. That's the meaning of a group. The group shares whatever attributes they are grouped on. So that, which means these two are in group, first group or group one, I mean one of the groups. These two is again in another group, and this one is the last group. This remains in a group of its own. Now what you're trying to say is, after you group them, now you do this aggregation on each group. Okay. So essentially this aggregation is not done on the entire relation, but on each group. So what will be the answer for this? Here is the answer. So what does it say? Is that, look, for this group whose value for A is 1, I am doing the sum, and that comes out to be 5 plus 5 equal to 10. Okay. For the group 2, I am again doing the sum on C, which comes out to be 30. And for the group 3, well, there is only one tuple, so the sum is only 8. Okay. Correct? Okay. So the question is, how did you determine that the first two rows will be grouped? Very good question. So can anyone try to answer that question? So the question is, how did you determine that the first two rows will be grouped? So why did I say that these two will be in one group, and why not anything else? Can anyone Try to answer the question. So let me try again. Okay, so what is the group that I am basing it on? This is this attribute A, correct? Please note that there is an A, subscript A before this grouping operator A. So what does that mean? That group based on this attribute A. Okay. So when I say group based on the attribute A, what I essentially mean is all the tuples that share the value of A, that share the same value of A, will be in one group. Okay. So let us look at the value A of the first tuple. What is the value A? It's 1. So what other tuples will be in its group? Every other attribute that has the value 1. So the only other tuple that has the same value A is the second one. So the second one is also in the group of the first one. So that's why I said the first two tuples, first two rows are grouped together. And why is the third one not in their group? Because they do not share the same value of A. So the value of A for the third tuple is 2, while the value of A for this group is 1. So this starts forming a group by itself. And the fourth one joins the group of this one. And the fifth one again starts a group by itself, right? So that's why there are 3 groups, the group of 1, the group of 2, and the group of 3. Okay. All right. Is that clear? Great, thank you. And so for the group of 1, I am then applying this aggregation operation sum C, which comes out to be 5 plus 5, 10. For the group of 2, this comes out to be 13, and the group of 3, it remains 8. Okay. All right, great. Let's see. If I do this, if I now specify more than one attribute to group, can anybody guess what the answer will be? So what am I grouping on? Remember, whatever the attributes I'm specifying for the group, for a group, they all have to share that. They all have to agree on the values, same values of that. Okay. Which means 1, 1 and 1, 2. Will they be in the same group? They will be not in the same group. The reason why they will be not in the same group is that although their A values match, their B values do not match. So they will not be in the same group, because for them to be, for 2 tuples to be in the same group, they must agree on both A and B, right? So that is why 1, 1 will be in a group by itself, and this 2 will be in a group. It will be in the second group. So 1, 2 and 1, 2, they share both A and B. That's why they have to be, they will be in the same group. So there will be 2 groups, and the answer will be this. In the first group, this is only by itself 5, and the second group, this is 1 to 5 and 1 to 4. So they share the group, and so the answer is 5 plus 4, 9. Is it clear to everybody? So now the same concept is there in SQL. There is this aggregation functions and grouping, and it again works on these 5 standard aggregation functions: the average, mean, minimum, maximum, sum, and count. Okay. So for example, if I want to find the average CPI of students, just overall for all the students, all I need to do is just say select average CPI from students. That's it. Okay. Very simple. Then I want to find the total number of students. Again, I can just say count roll. Just count the number of roll numbers. Very good. Suppose I want to use grouping. So just to go back. So this, when I'm not grouping, I am doing this on the entire set of tuples that are from the student. Okay. Now suppose I want to group based on, so for example, look at this query. The query is find the number of students in each department. So I am not interested in the overall number of students. but what I'm interested in the number of students in each department. So how do you do that? Now, so what does this query essentially mean is that first you group the students according to their departments, and then on each such group you find that count, right? Great. So for grouping, what is being used is there is an operator called group by, right? So the answer to this is let's see. So from student, you first group by department, okay? Which means first from all the tuples of student, you group by, so you group them by the department. And then for each such department, select the department and then you count the roll. So this first part is essentially just like that GA sum C kind of thing, right? That's exactly what we are doing. So the syntax here is a little different, but it's almost the same in the sense that what you're doing is, okay, you're saying, okay, from the student, you first group by department, then you select the count roll from that and the department, okay? Okay, and remember that anything that is here, this department, anything which is outside the aggregate function. So what I mean by outside the aggregate function is this role is inside the aggregate function, right? Because role, the attribute role appears in an aggregate function, and the aggregate and the attribute department is outside because it does not appear in any aggregation. So that has to be in the group by. Okay, great. Okay, so should we stop here? What is the time constant? Should we continue this SQL next class, or can we continue a little bit more? I'm not sure of the time because it's already 7:26. Should I mean India time, 7:26 p.m. India time. So do we have to stop within 4 minutes, or can we continue a little further? What's the all right, so I'll continue a little bit more and then I'll stop today, okay? So what I will continue is that there is something called qualifying the groups, which means that I may not be interested in all the groups. I may be interested in only certain kinds of groups. So for example, suppose I want to find the average grade in each course. How will that be done is that I will find out from the grade sheet. I will group by the course and I will do the average grade. But suppose I am not interested in every course, but only in those courses where the number of students is at least 5. Okay, so if there is a course with less than 5 students, I'm not interested in finding the average. That is done by using this having clause. So let's see an example. So which means is that from registration, I'm grouping by course code, but from all the groups there, I'm not interested in everything, but only those that have the count of that roll is greater than equal to 5. Okay, so only the count of roll greater than equal to 5 is what I'm interested. And then for all of that, I want to find I want to select the course code and the average grade, right? I essentially want to find the average grade, but not for all the groups, but only those groups that have this count roll greater than equal to 5. Okay, great. So what it means is that having is applied after forming the groups, and the predicate in where is applied. So if there is a predicate in where, that is applied before doing so. But I hope all of you have got this idea of what does qualifying a group mean. So essentially, after forming the groups, I do not want all of them to be processed. I want only some of them to be processed. So I can have that by this count or whatever. I can have that by using anything there. Okay. So I can have that by this having clause. Okay. So let's do one more example, which says find the average grade in each course type where this number of students is at least 5. So I can do this whole thing here, right? Again, I can have this entire where code and I can have this count again by having this count, etc. Okay. I think we can stop here today. Is that fine? We will continue with SQL. I think I'll require one more class for SQL, and then I will move on to NoSQL databases, etc. Okay, is that fine? So I'll stop here today. So if you have any questions about whatever has been taught today, etc., please do ask right now. All right, good. So one question is that I'm using examples using SQL, but you want some real data to be actual data to be done. So there is one I will post in a reading list where there is a website called pdmdbook.com. I'll post the link where you can actually go ahead and play with the databases. You can actually look at their table structure. You can actually type in some SQL query. It will give you the answer and all those things. And I will also post some example schema. And so whatever we are studying, this course code, etc., we will also post in some example schema and some example queries that I will post it in the reading list. So you can go and put that database there and push in some data, and you can play around with that. That will be the best thing to do. Okay. All right, with actual data, you can also play around, and I will also show some more examples. Okay, with some tables, etc. I'll show next day. I mean, I'll have more things to show with actual real data next day. Okay, all right. Okay, all right then. So let's stop here today, and we will start again next week. Are there more questions or suggestions? Okay. Bye.